So next topic is how to construct a Mealy machine, that is designing Mealy machine. Okay, so you already studied about Mealy, what is Mealy machine in the previous video. So automata divided into two types, finite automata with output and without output. Without output category, that is DFA, NFA and epsilon NFA, that you already studied what is DFA, how to construct a DFA, what is NFA, how to construct, what is epsilon NFA, how to construct epsilon NFA and the conversion between them also. Okay, and with output category, Mealy machine and Mealy machine. Mealy machine I already taught you how to design a Mealy machine. Okay, and Mealy machine, today I am going to explain you how to design a Mealy machine. So what is Mealy machine? So Mealy machine is a machine which belongs to the category finite automata with output. Okay, here you can see the output on transition. In Mealy machine, you can see the output along with the state, output alphabet along with the states. In Mealy machine, you can see the output along with the state. So each state will produce some output. But in case of Mealy machine, instead of putting output along with the state, you can see the output along with the transition. So in Mealy machine, the output is on transition. Q0, while seeing the input symbol A, it will produce the output 1. Q0, while seeing the input symbol B, it produces output 0 and reaching state Q1. From Q1, if the input symbol is B, it will produce as output 0. And from Q1, if the input symbol is A, it will produce as output 1 and reaching the state Q0. Okay, so output is on transition. And both machines are represented by using 6 tuples, Q sigma del delta, Q0 lambda. Q set of finite states, sigma is a set of input symbols, delta is output alphabet, this is the transition function, this is the starting state, and lambda is the output function. In case of Mealy machine, what will be the lambda? It is Q cross sigma gives delta. That is, output depends on the current state and the current input symbol. Okay, the output 1 depends on the state and the corresponding symbol. Each, so here also this output depends on this state and the input symbol. Okay, so output depends on current state and the current input symbol. And both the machines are deterministic, so the transition function is Q cross sigma gives Q, like DFA. Transition function like DFA. We can't say both Mealy machine and Mealy machine are DFAs, but both are deterministic machines. So now we can see how to construct a Mealy machine. Suppose this is our problem. Construct a Mealy machine that produces the ones complement of a binary number. What is ones complement? If the input is 1, the ones complement of 1 is 0. For 0, the ones complement of 0 is 1. Okay. So if our input is 1, 1, 0, 1, what is the ones complement of 1, 1, 0, 1? 0, 0, 1, 0. That is 1 becomes 0, 1 becomes 0, 0 becomes 1 and 1 becomes 0. Okay, this is the ones complement. So our problem is to construct a Mealy machine that produces ones complement of a binary number as input. Okay, so I am just drawing the state, starting state Q0. Okay, so whenever we are seeing 1, it will output 0. Whenever we are seeing 0, it will output 1. So how to draw the automata for this one? Whenever we are seeing 1, it will output 0. Okay, whenever we are seeing a 0, it will output 1. Okay, so we need only one state here. Okay, from this state, whenever we are seeing 1, it will output 0. Whenever we are seeing a 0, it will output 1. So in the same example, we can see here. So we Q0 starting state, while seeing the input 1, it is moving to the state Q0 itself and the output 0. Then Q0, again seeing the next 1, it will go to Q0. While seeing 1, it will output 0. Then Q0, next input symbol is 0. So 0, it is moving to Q0. 0, it is moving to Q0. While seeing 0, this will output 1. So this will output 1. Then next input symbol is 1. Next, so Q0, while seeing the input symbol 1, it is moving to state Q0 and displaying the output, producing the output 0. Q0, while seeing the input 1, it is moving to Q0 and output 0. So this is the last bit. Okay, so when the input is 1, 1, 0, 1, it will produce as output 0, 0, 1, 0. Look, this is a ones complement of this number. This is a ones complement of this number. 1, 1, 0, 1, 0, 0, 1, 0. Okay. So this is the answer. This is automata for the given problem. That is constructing a Mealy machine that produces the ones complement of a binary number. Okay. Then how to construct a this is a transition diagram. How to construct a transition table. So we need to mention the states here. Only one state is here. Q0 while seeing the input symbol 0. Q0 while seeing the input symbol 0. It is moving to the state Q0 itself and producing the output 1. So Q0, comma 1. Q0 while seeing input 1. It is moving to state Q0 and output 0. Q0 while seeing the input symbol 1. It is moving to Q0 itself and producing the output 0. That is Q0, 0. Okay, so in this way you can construct the transition table also.